What is DNA methylation and why is it so important to your health?
Yeah. So as I mentioned, these are providing the codes for exactly what your DNA should be doing, what these cells should be doing. And so, the DNA provides what I call the blueprint. But this in order to actually make any sort of actionable change in your body, it's happening through the expression or regulation of what genes are turned on, and therefore what proteins are encoded and how the body's actually functioning. And so, this is important for every cell type. It tells your skin how to behave, and improves, for instance, your wrinkles. If we wanted to, we can make certain changes to make sure you have less wrinkles or less photo aging, or we could make it so your muscles generally lose less tissue over age, and you don't have as much frailty with age. And these, I should say, these codes or these signalings are important for every process that happens in your body, and dysregulation of those processes are what cause eventually these diseases to develop. But for us, we're really looking at epigenetic methylation as the main marker here. And epigenetic methylation is essentially a silencing of gene transcription. So it's that off switch, so to speak. So it's sort of when genes are turned off, we'll see methylation at higher levels, and that can tell us again if something's abnormal, or if something is sort of where it should be, or if it's something that we want to change. And so that's really what we're quantifying. We measure right around 900,000 locations in your genome, and at each location we're essentially getting a number, a percentage between 0 and 1, and then we're looking at how often is that particular location methylated in your blood. And that, with that information, we're able to develop these algorithms to be able to interpret that output into clinical features. And so, as I mentioned, we might use these computer learning derived algorithms to predict death. We might use it to predict, your VO2 max in terms of how fit you are. We might be able to do it to tell you, how your immune system is functioning. And so we can do a lot of different things with this data because it's so complex. But methylation is really the way that we're doing it, by looking at how those genes are turned off.
Great. So it sounds like we have a bunch of off and on switches. Some are good, some are bad. And the key to longer term health is to try to figure out which ones are beneficial to be turned on, which ones are beneficial to be turned off, and then take appropriate action to make those switches switch the right way.
Exactly, and I always like to say, use the analogy of the Rosetta Stone. Right, the Rosetta Stone was a great tool to be able to help interpret a new language, and that's exactly what we're doing here at True Diagnostics is trying to develop the Rosetta Stone of how to interpret these methylation marks. And as you mentioned, methylation is not always good; it's not always bad. In order to see those associations, we really have to look at how these marks associate with outcomes. So we might look at, for instance, disease-related outcomes. Maybe methylation in one spot's great to prevent cardiovascular disease, but in another, we might see that it actually leads to worse outcomes of cardiovascular disease. And so we're really just learning how to read that DNA patterns to be able to tell you what's currently happening in your life. And with that, we can get incredibly specific. And because these things are temporal, or they change in time, it can really tell us, both the history, but also what's currently happening now. And so by comparing those two things, we can sort of say, hey, here's where you've been, here's where you're going, and here's how we change it.
Right. And then I think this is a valuable service because as the data set grows and as you get more and more of that and aggregate it and figure out more complex algorithms, there's more value in all of that data.
Absolutely. And I think some of our clients have even seen this already. Whenever we first rolled out our testing about 2 years ago, we only had one output, which was, what is your body's age? How old is your body aging? And this is a very important thing because, we all know people in their 50s who look like they're 70, and we all know people in their 70 who look like they're 50. And this is called phenotypic variation. And, chronological age doesn't capture that difference, right? But we can see it. And so we really need something to measure the biology of that process, right? Something that can sort of tell us why we're seeing those differences. And so that's what we developed, at least initially, is this idea of biological aging. And it's a concept which is really changing the way that we look at age, which is already, even chronological age, is the number one biggest risk factor. But so whenever we first rolled out, we just had that one report. But now we have over 11 or 12 that have been added to any of our patients who take our tests, because we're able to analyze that data in more complex ways. And we'll continue to add reports just about every 4 to 6 weeks. And so now, in addition to that overall biological age, we can tell you things like your immune age and all of what types of immune cells you have and at what percentage. We can tell you things like your telomere length, which previously used to be sort of the best biomarker for aging, which now these markers definitively beat. We can tell you even right now how fast is your pace of aging. So at the moment that we take the test, what is sort of your speedometer of aging at this exact moment? We can tell you how many stem cell divisions you're having per year. We can tell you what your current level of drinking is, if you're a current, former, or never smoker, and all of these things are included in our reports, and they weren't even just 2 years ago. And so the amount of information is it's a little bit like Moore's law, where we see, we might look back at, some of those computer chips in the 80s, and now we can do it with just, even flash drives that are, half the size of your thumbnail. It's very similar to the gains that we're seeing in being able to interpret biological data. Now that we have computer learning and these ways to really see patterns in ways we haven't before, the amount of information we can pull from the same data set is growing at an exponential rate. And this is affecting all areas of medicine, as I mentioned, but definitely aging. And that's really, I think, something that we've been trying to fight for, is viewing this idea of aging as a disease.
Yeah, it's great. And I think it's also will impact quality of life. We live in a society now where I've seen so many of my people my parents' age, I'm 52, they started having problems in their 50s. And then it's a real sort of gradual downhill slide with more and more physical ailments encountered over time. Whereas if we could address that and avoid that, and hopefully, have another 20, 30 really good years where we're very healthy, that's where the data, I think, would be really beneficial.
You're exactly right. And I think that that's an important thing to mention, because a lot of people think about longevity. They think, why would I want to live another 10 years if I'm going to live in a nursing home and, someone's going to have to wait on me and I'm going to be miserable. And I always like to say that those things are not mutually exclusive. If you're treating aging as a process, you actually improve all of those quality of life measurements. And we have some really good pictures that show this. We can even see that the rate of aging, that pace of aging I mentioned, is correlated to how much muscle mass you have. It's correlated to how your IQ. It's correlated to the ability to balance. It's correlated to even your facial aging. So even the way you look and move about the world, and the way that you even are able to think about the world, is all affected by this fundamental process we call aging. And so they're not mutually exclusive. If you're improving your aging rates, not only are you making your life longer, you're making your life better from a quality of life standpoint. And that's exactly what you want to see, because unfortunately we have a little bit of a health span problem here in the United States. We might be seeing, our ages, or the average age of death, get a little bit older, but we're actually seeing that time that we spend sick significantly widening. And the fact is that aging treats both of those. If you can treat aging as the primary cause and driver, then you're essentially finding solutions for both quality of life, health span, and lifespan.
Yeah, absolutely. So I had your test taken, so I'm excited to go over the results. We'll probably do that in another podcast.
All right. Well, thank you so much for the time. If there's anything you need from me, just let me know.
Perfect. Listen, thanks for joining us, and we'll catch you on another one.